we're going to explain how to calculate the error function on a Casio calculator. The error function, often denoted as erf(x), is a special function in mathematics and doesn't have a direct key on most Casio calculators. However, we can calculate it using the calculator's capabilities. There are two main approaches: using the Taylor series expansion for approximate values, or utilizing the calculator's numerical integration function for greater precision. 1. Understanding the error function. The error function is defined as erf(x) equals 2p 0x et2 dt. This means it's the integral of a Gaussian function from 0 to x. Because there's no closed-form solution for this integral, except for specific values, we need to rely on approximations. 2. Method 1. Taylor series approximation. The error function has a Taylor series expansion, which is an infinite sum of terms. We can approximate the erf(x) by taking a finite number of terms. The more terms we use, the more accurate the approximation will be, but it will also become more computationally intensive. A common approximation uses a few initial terms: erf(x), 2p, x, x33, plus x5, 10, x7, 42, plus. To use this on your Casio calculator, you'll simply substitute the value of x into this formula, carefully calculating each term and summing them up. Keep in mind that this method will have limitations, particularly for larger values of x. Remember to use the calculator's parentheses appropriately to maintain the order of operations. For example, to approximate erf, 0.5, you'd calculate 2p, 0, 0.533, plus 0, 55.10, 0, 57.42. 3. Method 2. Numerical integration. More accurate results can be obtained by using your Casio calculator's numerical integration function. This function, the specific key or menu option may vary depending on your calculator model, consult your calculator's manual, approximates the definite integral using numerical methods. To use this method, you need to enter the integrand et2 and the limits of integration, 0 and x. The calculator will then approximate the definite integral, which is directly proportional to erf(x). Remember to multiply the result by 2p to get the actual erf(x) value. This method generally gives better accuracy than the Taylor series approximation, especially for larger values of x, but may require a bit of familiarization with your calculator's integration function. 4. Important considerations. The accuracy of both methods depends on the number of terms used, Taylor series, or the algorithm employed by the numerical integration function. For very high precision, you might consider using specialized software or online calculators designed for this purpose. Also, remember to check your calculator's manual to understand the syntax for entering functions and performing calculations, especially for numerical integration. The exact steps for numerical integration might differ slightly depending on your Casio calculator model. Always ensure that your calculator is in the correct mode, radians or degrees depending on the context of your problem. By following these steps and consulting your calculator's manual, you should be able to successfully calculate approximations of the error function on your Casio calculator. Remember to always double-check your work and consider the limitations of each method used.